Right, this video is on functional notation. So I'm going to pretend you can't remember anything. Okay, so if we've got the function called f of x equal to 3x plus 2, and we're asked to calculate the f of 1. So what that means is, what is the value of the function f when x is 1? And how we get it is we just substitute a 1 in place of x in the function f. So that's 3 by 1 plus 2. So 3 ones 3 plus 2, 5. Okay, let's try negative. Say negative 4, the f of negative 4. The value of the function f when x is negative 4 means replace the x in the function f with a negative 4. So 3 by negative 4, negative 12 plus 2, negative 10. Okay, let's try a variable. So you want the f of a. That just means wherever there's an x in the function f, we need to write an a. So here we'll have 3a plus 2. And what you're going to have to get really comfortable with is the f of x plus h. So that means in the function f, wherever there's an x, write x plus h. Okay, multiplying in the 3 gives us that. Right, the reason why you need to get comfortable with that is on your formula sheet, you will see this formula here, which reads f dash x equal to the limit as h tends to 0 of the f of x plus h minus the f of x all over h. And it's this part of that formula that we're going to concentrate on today, so that when you come to do calculus later on this term, hopefully you'll be very comfortable with it, with this part of it anyway. Okay, so first example, I'm going to keep to the one we've just done, which is the f of x equal to 3x plus 2 linear function. We've worked out that the f of x plus h is 3x plus 3h plus 2. And now we can substitute into the formula the f of x plus h minus the f of x all over h. Right. So the f of x plus h is the 3x plus 3h plus 2. I'm writing that down. And the f of x is the function that we were given, is 3x plus 2. So we've got to subtract the f of x. So put it in brackets, just to avoid making dumb mistakes of signs. Because remember, there's that invisible 1 in front of the bracket that we need to multiply in. So then we have 3x plus 3h plus 2 minus 3x minus 2 all over h. Collect like terms. 3x minus 3x, 2 minus 2, and we'll end up with 3h over h. The h's will divide. Answer 3. Cool. Okay, number 2. Right, that was a linear function. Now we're going to try a quadratic function. F of x equal to x squared plus 4. We know we're going to need the f of x plus h, so I'm going to work that out quickly. The f of x plus h means in the function f, wherever there's an x, replace it with x plus h. So that's x plus h squared plus 4. And you know that x plus h squared is not just x squared plus h squared. Correct. Because it's x plus h multiplied by x plus h. So multiplying out x squared, x by h by h, inners, outers, the same, 2 of them, 2xh plus h squared plus 4. Right, now we're ready to substitute into the formula the f of x plus h minus the f of x all over h. Okay, in place of the f of x plus h, I'm going to write x squared plus 2xh plus h squared plus 4, because the f of x plus h is equal to all of that. From that we'll subtract in brackets to avoid making silly mistakes x squared plus 4. Because remember, f of x is always the given function all over h. Then multiplying in the negative, collecting like terms, 4 minus 4 gives us 2, forgot the h, xh plus h squared over h, because I was just about to say to you, if at this stage you can't take out an h from every term in the numerator, you must know you've made a stupid mistake, which is exactly what I did. See, I forgot to write down that h, 2xh, and I just wrote 2x, which is dumb because then I couldn't have taken out a common factor. Okay, so sort out my paper. Now, fortunately, we can take out an h, and we're left with 2x plus h all over h. The h's divide. We get 2x plus h. That's the answer. Okay, number 3. I'm going to keep to quadratic functions for now. Number 3, okay, let's call this g of x, because they don't all have to be x's. So this is g of x equal to x squared. I mean, they don't all have to be f of x's. G of x equal to x squared minus 3x. Okay, we need the g of x plus h. So everywhere in the function g, wherever there's an x, replace it with x plus h. Now in this case it's in 2 places, so there's more work to do. So it'll be x plus h all squared minus 3 by x plus h. So that's x squared plus 2xh. Remember, your outers and inners, plus h squared minus 3x minus 3h. Right, now we're ready to substitute into the formula, and I must use g now because the given function was called g. So it's g of x plus h minus g of x all over h. And we've worked out that the g of x plus h is equal to x squared plus 2xh plus h squared, all of that. From that, we'll subtract the g of x, which is the given function, in brackets. So so you don't make mistakes with signs. All over h. So then we get x squared plus 2xh plus h squared minus 3x. All of this, don't forget to multiply in the negative. That's all over h. Collect like terms. Plus 3x minus 3x. Check quickly, does every term have an h in it? Yes. Okay, so far so good. All over h. Then we'll take out a common factor of h. Divide the h's. And final answer, 2x plus h minus 3. Right. Example 4. Keeping two quadratics. And this time calling it h. Just don't get confused with the function called h and the h in the formula. Right, they have two totally different meanings, and when you actually start calculus, you'll know what it is. Okay, so we need the h of x plus h, which means in the function h, wherever there's an x, which again is in two places, we're going to substitute x plus h. Here you have to be super careful because we have that calculation there, the squaring, following on a negative. Okay, watch out for that. So it's 2x plus 2h minus x plus h all squared, x squared plus 2xh plus h squared. And we need to multiply each term in the bracket by that negative, not just the closest one, each one. Okay, now we're ready to substitute into the formula. The h of x plus h minus the h of x all over h. Okay, careful, different h's. H of x plus h is all of this. Okay, from that we'll subtract 2x minus x squared and put it all over h. Here we have 2x plus 2h. All of that. Multiply the negative in, minus 2x plus x squared. All over h, collect like terms, 2x minus x squared plus x squared. We're left with those three terms. Check that they each have an h. They do. Take it out as the common factor. Check that quickly, all over h. Then next step, divide the h's, and we're left with 2 minus 2x minus h. Cool. Right. Example 5. So I think, don't you, that you could try this yourselves. F of x equal to 2x squared minus 3x plus 4. All right. Will you try it yourselves? Work out f of x plus h and then substitute into the formula f of x plus h minus f of x all over h. And I'll do it as well, and we'll compare answers, and you can tell me if I'm correct. Right. number 5. Okay, pause the video or whatever you do and work it out, and I'll work it out same time. Noisy pen. Lots of work. Collect like terms. Check for H's. So far so good. Take it out. Okay, it's taking it out of those 3 remaining terms. Divide the H's. Okay, do we agree? Hopefully. Okay, number 6. Right, we've done linear and quadratic functions. So, time for cubics. F of x equal to, let's do negative 4x cubed. So we need the f of x plus h, negative 4 by x plus h cubed. And of course, x plus h cubed is not just x cubed plus h cubed, because what it is 3 factors of x plus h. Lots and lots of work. Right, taking it slowly. Slowly, because it's not worth rushing. Okay, this is like 5 or 6 marks in your exam that are pretty well within your grasp, that you can get, like marks to bank. Okay, multiplying those 2. So you need to practice quite a bit so you don't make silly mistakes and you can get all your marks. Okay, so we need now awful lot of multiplying. X by x squared. X by 2xh. X by h squared. Then h by x squared. X squared h. H by 2xh. 2xh squared, and of course I always put the bracket in too soon. H by h. H cubed. Okay, then eventually multiply in the negative 4. Okay, No. Let's see if there aren't any like terms. That would make life much easier. There we go. So we have 2x squared h plus 1x squared h, 3x squared h, xh squared plus another 2, 3x h squared plus h cubed. Now, time to multiply in the negative 4. Right, grade 12, eh? Right, f of x plus h minus the f of x all over h. Oh, grade 12 is not for sissies. Okay, f of x plus h, all of that. Minus the f of x, which is negative 4x cubed, all over h. Okay, so now I'm going to do every step. You don't have to, if you don't make stupid mistakes. Okay, so minus negative plus 4x cubed all over h. Then collect like terms and check that every term that's left has an h that can be taken out as a common factor. Yep, take it out. Remember, it's not the highest common factor. We're only interested in an h to divide, whoops, with the h in the denominator. And we're left with negative 12x squared minus 12xh minus 4h squared. Cool, right, so we've done linear, quadratic, cubic, and finally, last kind we need to do is a hyperbola. Okay, I'm going to call this one G. So let's say G of x equal to, what? Let's make it 5 over x. Right, G of x plus h, 5 over x plus h. Easy. So, what's the catch? Well, let's have a look. G of x plus h minus g of x all over h. G of x plus h, 5 over x plus h minus the g of x, 5 over x, and all of that is over h. So what we have here is what we call a complex fraction, because it's a fraction over a fraction, complex. So what I suggest that you do is write down the numerator, put it in brackets, so it's one term, and that is divided by h. You know that dividing by h is the same as multiplying by 1 over h, because this is h over 1. Right, here inside the bracket, we'll get a common denominator of x by x plus h. Multiply the 5 by x and the negative 5 by x plus h. We then have inside the bracket in the numerator 5x minus 5x minus 5h. collect like terms. We're left with negative 5h over x by x plus h. Don't multiply out, okay? H's divide. They have to divide, okay? So there's got to be an h there. We then get negative 5 over x by x plus h. And that's the answer. Okay, so not too complicated, manageable. Just be careful. Okay, now an exercise for you to try. If you write these questions down, and then I'll do the solutions and upload the solutions as soon as I'm done. Right, practice exercise on functional notation. And that's it.